Hey everyone, welcome back to my channel, 2Min Maths. Today we'll be discussing what the rational root theorem is. Well, we can see in this given polynomial that the fact that the zeros are -5/2, comma -3/4, comma -7/8. Well, we can notice that the numerators are actually factors of the constant term, which is -105, and the denominators are factors of the leading coefficient. Well, these observations are generalized by the rational root theorem. So what is this rational root theorem? Well, let's say you're given a polynomial which has integer coefficients, then every rational solution of f of x equals 0 has the following form. So the factor of the constant term and the factor of the leading coefficient. And the leading coefficient is attached to the highest degree in the polynomial. So let's say we have to find all real solutions of this given polynomial. Well, step one is to list all these possible rational solutions, and we can do that using the rational root theorem. It's important to note that the rational root theorem only gives you the possible solution, so you actually have to test them out. So as you can see, the factors of 20, which is our constant term, is 1, 2, 4, 5, 20, and also the negatives of that. And the factors of our leading coefficient, which is attached to x to the power of 3, and the leading coefficient is 1 in this case, would just be only 1 and plus or minus 1 since they're both factors. That's why you can see the plus or minus sign for all the factors. So now we can actually test these possible solutions using synthetic division until a solution is found. So it's actually best to start off with the lowest numbers and then keep going high. But we're just going to start off with x equals 1. And if you don't know what synthetic division is, it's basically a shortcut for dividing a polynomial by the binomial x minus k, and you can find all the information about that in my previous video. So again, we just bring it down, we multiply all the numbers, you know how synthetic division goes, hopefully. And we can see that actually the remainder is 24, which is indeed not a factor. Well, we know that it would be a factor if the remainder would be a 0. So let's actually test x equals -1. And let's set up all the coefficients, and let's repeat the process of what we did previously. And you'll actually come to notice that indeed 20 minus 20 is 0, and indeed x equals -1 is a factor. Well, now we have to write this in factored form. And we can see that it is indeed a factor because the remainder is a 0. And in order to write this in factored form, we know that if x equals -1 is indeed a 0, we can write it as x plus 1. So therefore, x will be equal to -1, and -1 plus 1 is 0. And we can see that the remainder is x squared minus 9x plus 20. So we would write it in this given form. Let's say our step 3 is writing down our updated polynomial in factored form. And as you can see, we would write it as x squared minus 9x plus 20 times x plus 1. Now the x plus 1 was derived as x equals -1, and we saw that that is indeed a factor because x minus 1 plugging in x equals -1 worked. Okay, now we factor it out, and a quick review is that the second term in the polynomial adds up to the b term but multiplies to the c term. So -5 plus -4 equals -9, and -5 times -4 equals 20. I hope this video helped. Comment down below any other math topics you want me to review. Thank you.